In this recording, we're going to learn some properties of logarithms. Just like exponents have rules, well, logs are exponents, right? So they have pretty similar rules. Let's identify them. We're going to do so abstractly because mathematicians, we like to identify our rules without specific numbers. So the A and R and S can represent lots of different numbers. However, there's certain numbers that we have to restrict them to. Okay? So I'd like you to write down on your paper properties of logarithms. Then I'd like you to just put a little note that A, R, and S are going to be positive real numbers, and then we're not going to let A be equal to 1. Okay? First rule, product rule. Product rule looks like this. It's kind of like the exponent rule. We've got something like this. X to the fifth times x to the sixth. You add those exponents, right? When you have a product. So these are exponents. They're logs. All right. So when we take the log of a product, we're going to add them because logs are exponents, right? So we've got something like this. Log base a of rs is equal to log base a of r plus log base a of s. Now I know right now, so far, it doesn't make sense to you. That's okay. We'll work with it. Okay? It's not going to make sense quite at first, but you can see how it's analogous to the product rule with exponents. Think about our quotient rule with exponents. Got something like this. X to the 12th over x cubed. You'd subtract the exponents. So when I have a quotient, I'm going to, I've got a quotient, log of a quotient, I'm going to subtract the exponent. So I've got log base a of r minus log base a of s. Okay, hopefully that makes a little sense, that they kind of working together. Last rule, power rule. Okay, I've got x cubed raised to the seventh. We'd multiply these exponents, right? Exponent to the exponent means multiply them. Well, look what I've got here. I'm going to put parentheses around log base a of r. That's an exponent, right? It's an exponent because it has, it's log, right? And this little c is an exponent because it's written where an exponent would be. So if you have an exponent raised to an exponent, think about what we did. We multiply them. And when we multiply, we can essentially write it in front. So this is the bring it down in front rule. C times the log base A of R. And you can put a little dot there so it doesn't look like clog. All right, we don't need to say clog. C times the log base A of R. Let's bring our note here. Little note. Bring exponent down in front, right? Just like you're at a baseball game and someone's not sitting down. You want to watch the game, you say down in front. That's what we do here. Down in front. Okay? So those are our three properties. The power rule, product rule, and quotient rule. Let's box them in. If you're asking, are we going to need to memorize these? You do, but you're going to use them so often that hopefully you'll commit them to memory. It won't be a thing where you have to just like make flashcards or something. Okay, so let's box these three rules in. And again, I would encourage you to write the similar exponential rule so you can refer to it. Okay. Finally, just a review of some properties. If we have log base a of a, in other words, saying basically, what's the exponent that we'd raise a to get an a? Well, that'd be a 1, right? And then what's the exponent I'd be raising a to get a 1? Well, as long as a is not equal to 1 and it's a positive real number, that would be a 0. Right, so those are important to know. And finally, we should know stuff about exponents and radicals, right? Converting between those two forms, exponential and radical form. So this one, say power over root. There's the power, but where's the root? 2, right? So we go a to the half. And this one, power over root 7 over 3. Those are your properties of logarithms. Thanks for watching.